Alright, we're going to keep going with this chain rule examples, and we're going to be looking at this kind of difficult problem that there's a lot going on and we have to find the derivative of. So let's see. Y equals that. Cosine squared of x cubed plus x squared. This one looks really complicated because there's a lot going on, but usually when you're tackling chain rule problems, it's always good to represent something more nicely to make it more understandable on which one's the outside and which one's the inside function, right? So I'm going to actually rewrite this as cosine of x cubed, x squared, all of that squared. That looks so much more nicer because now I know exactly what's the inside and what's the outside functions. But in this case, there's actually three parts to it. There's this function, the x cubed and x squared. There's this function, the cosine, and then there's the squared. So it's a triple composition is what I like to call it because there's three things. So this one takes quite a while. So take the derivative of the outside and keep the inside the same, right? 2 times cosine of x cubed plus x squared, and we want to change the derivative with respect to x of whatever's on the inside. Okay, and then now we just want to look at this derivative. We want to take the derivative of the, now this is the outside function, right? So negative sine, and keep the inside the same, and then multiply by the chain, 3x. Remember to put parentheses here because this is treated as one thing, like the derivative of the inside. It's not just the first term without the parentheses. It's not like this, because then this is wrong. You have to put the parentheses because you have to treat it as one thing. And then we just combine it all together. So to make it nicer, let's do it like this. Let's put the polynomial thingy out front. And then let's make the sine go first. And then make the cosine go second. Right? So that's the derivative of that. Let's do one more. How about that? An easier one. Find the derivative of this. Tangent to the 4x squared. Right, so now we're moving on to the second problem. Alright, so this is what the function is, right? So we want to look at the inside and what the outside is, right? Let's do this one, and then let's do one more after this, just to see something. So the derivative of the outside is secant squared 4x squared, and then we want to multiply by the chain, right? This one's an easy problem, and we're done here. Let's do the same thing to this one, right? So this is a new problem. Let me move it over. This is the second one. This one was an easy problem. Now we go on to the third one. Secant of 4x squared. So the derivative of secant is secant x tangent x, right? So secant, you want to keep the inside the same, and tangent, you still also want, because the x is the same, or the inside of the secant tangent is the same, right? Even though x appears twice, you're still the same inside function. Just remember that. I just wanted to point that out, and then you multiply by the chain, and then we're done.